Hi. Hello, I'm Benjamin. I'm in South Carolina. Where are you? Put me down, please. Oh, there it is. People already joined. Can I hear it, please? Yes.
Wait, are we supposed to be one?
Right. Well, hello, everyone. How's everybody doing? You guys can turn on your cameras if you'd like. It's much more fun to see people's faces and to talk to faces as opposed to a black screen. So we do prefer the video to be on. We'll get started in a couple more minutes. We had 100 people register.
How's it?
So we'll see if they all show up or not.
So you can watch the thing, okay? All right.
You guys can stay on mute for now. We will do a question answer, or if you raise your hand, we might call on you, but we'll try and keep mute just so there's not a lot of background noise and so forth. So you can stay on mute, but turn on your videos if you would. Hi, Jacob. I see you waving. Jacob, who said he's from North Carolina. I'm from North Carolina as well. Nice to see you. We have people that registered from all across the country, from Alaska, California, Washington, Texas, North Carolina, Florida, Ohio.
Mom, why don't you do that, Mama?
All kinds of, yeah, all across the country. Oh, we have more from North Carolina. Awesome. Sammy's in Alaska. Somebody's in Thailand? Well, who's in Thailand? Who said that? Tony, right?
I'm getting 400
Oh my gosh, you get the most international award. Wow,
And the last one is nobody has.
All right, whoever's chatting, if you can mute.
And then get I would do that.
All right. Okay, I'm gonna keep everybody muted. Hi, Miles. All right. All right, well, we're at 7:30, so we're gonna go ahead and get started. I am gonna record the presentation. So just so everybody knows that you are being recorded. We're not gonna post this out publicly, but we want a copy of it for our records. And but anyhow, we're very glad you're here. Thank you for joining us. This is a pretty unique opportunity. So I'm glad you all chose to be a part of it. We have a very full schedule in terms of what we're going to cover tonight. So Andrus, I'm going to give an introduction to Andrus. I just saw you there. You are Andrus. Okay. All right. So anyhow, we're excited to have Andrus Black here. He is a starship engineer. He has a crazy title. He is a starship engineer working for SpaceX. He works directly on the rocket that's going to go to Mars eventually. This is very different than the rockets that launch out of Florida, the Falcon rockets. Those are smaller rockets. They're very cool and amazing too. And I'm sure Andrus will talk about this, but he works on the very large and huge rocket that is ultimately designed to go to Mars. It's very large because it takes a lot of fuel, and they're going to carry cargo eventually to Mars. And so it has to be much bigger than the other rockets that go to the space station and into orbit. So anyhow, so he's going to talk about all of that. Andrus is a graduate from the University of Colorado Boulder. He graduated a year and a half ago. He's my son. He is my number. I have 4 children, and he is my number 2 son, or my number 2 child, I should say. First son, second child. So he's number 2 out of 4. He and I actually jointly started Home Hacker Camp when he was in middle school. Oops, I forgot to record. Let me start this recording.
Recording in progress.
All right. So he and Andres and I started Home Hacker Camp when he was in middle school. I was heavy into software development and design for a big company in Los Angeles, and then we moved to North Carolina. And there wasn't a lot of STEM programs here, and he was on the mechanical side, and so we joined forces and started Home Hacker Camp as summer camps. They actually started in our basement, which is where I am right now. When he was in middle school, and then we had a lot of homeschoolers attend, and we actually started, turning it into a full semester course for homeschool students. But this was a project that he and I started together many years ago. So anyhow, fast forward, he's always been interested in engineering, went to University of Colorado Boulder into aerospace engineering, and then immediately applied to SpaceX and has been working there since last June. So June a year ago. So about a year and a half now. So anyhow, we're happy to have him. Andres, I'm going to put you on spotlight, and I'm going to let you take it away. We'll keep everybody on mute for now. If you'll turn on your video, it's much better to speak to faces. We've got people from all over the country, I guess, and even the globe. We even have somebody from Thailand. Anybody else further away than Thailand? I don't know how much further away you could get. But we've got Thailand, we've got Alaska, we've got California, we've got, we had over 100 people actually register. I had to cap it out at 100. So, but anyhow, we're glad you're here, and I hope you learned something. All right, so Andres, I'm going to turn it over to you. Let me put you on spotlight. All right. And should I tell them that you've been sick? Well,
I'm sure that I'll be visible.
Yeah. So this was originally scheduled for October. And there was actually a big test launch that was going on. So that got Andres tied up. And I'm in Asheville, North Carolina, where the hurricane hit. So we were without power, electricity, and having all kinds of issues that we were dealing with here. And so for multiple reasons, it got canceled then. And so we got it rescheduled. And then now Andres he's based out of Boca Chica, Texas, which is where the Starship launches from and the development happens. And then now he's currently in Los Angeles tonight working at the Hawthorne office. And he ate some food the other night and got horribly sick. And he's been
recovered just in time for this.
But he has not been well for the last 2 days. So I was very nervous that we were going to have to cancel and reschedule again, but he has his food poisoning appears to have cleared his system now. So he was actually out of work yesterday and back today. So anyhow, all right, Andres, make sure you get your volume up good and talk loud, and we will take question and answers at the end and so forth. So we're glad you're here. All right, go for it, Andres.
Thank you. Can everyone hear me okay?
Give thumbs up if you can hear okay. Everybody give thumbs up, thumbs up, thumbs up, and turn your cameras on, please.
Cool. I'm going to share my screen if that's okay. Oh, I think you need to enable that. I should have asked you before.
Let me do
My fault.
that. Yep, hang on. All right, give that a try now.
All right, can everyone see my screen?
Yes, I can see it well. Everybody thumbs up when you ask the question, give thumbs up.
Awesome.
Got it.
Yes, that's a classic. Every single meeting that I run, every day I got to ask, can you hear me? Can you see me? Because I've definitely presented on some pretty big things and no one could see or hear me. So force of habit now. Cool. Yeah. So thanks, Mom. Yeah. So she covered some of this already. But to give some more context, yeah, I'm a Starship engineer. Work at SpaceX, which is Elon Musk's company. If you weren't aware, launched a lot of rockets, and the big new thing that we're doing that's very exciting is working on Starship, which is like a very Star Wars sounding name, but it is in fact a real rocket, and you can see a photo of it here in the background. On the left-hand side, you can see the launch tower, and on the right-hand side, you can see the rocket and all of the liquid oxygen and everything flowing around the area, all the condensation. So it's a very cool photo, very cool rocket. My journey is kind of started, obviously, like doing Home Hacker Camp in high school and being interested in technology. And then I went, like she said, I went to Colorado for college, and I studied aerospace engineering. And I love to teach and share my passion for engineering. Engineering is like just making things, and everything is making things. You're always making something, right? Dinner, working on your car, whatever. Everything is engineering. So I love that, and I love helping people find out what they want to do and what they like about engineering. So today, though, I'm gonna start like first half or third. I'm gonna give you guys a micro aerospace engineering lesson. And then I'm going to talk about what it's like to work at SpaceX, what it's like to study in school, how you can help like make the right decisions. And if you want to ever work at SpaceX, you might have a little bit of an advantage now. So, and then of course, like to answer some questions at the end if you guys have them. So let's get started. So our lesson today is going to be attitude control. Does anyone know what that means in the context of rockets? Oh, I did notice that my subtitle here came up one slide too early. That means, so the answer is on the screen, controlling vehicles in zero gravity environments. So attitude is kind of like our space term for orientation, how you point something somewhere in space, right? In space, you're not standing on any ground. So it's very hard to know where you are pointing. There's no gravity. So how do you know where you're pointing? Because there's no gravity to pull you down or nothing to stand on. So gonna quickly talk through how we control and orient rockets in space. And specifically rotating things in space. This is like the specific problem that had to be solved a long time ago, especially when we were going to the moon. How do you rotate things in space? So how do you move something in space generally? And like in a simpler way, how do you move something just straight, forward or backwards? And so to do that, you apply a force to it. Just like this little man is doing down in the corner. This is like a classic, if you guys are ever in engineering school someday or now, you will see a classic photo textbook where of a little man pushing a box, applying a force to a box, and you'll take many tests about how this man is applying force to this box. And he is moving the box forward by pushing on it, and he's moving it in a straight line. And so you apply a force to something. And what is a force? Well, like at a high level, it is, a push or pull on an object. So you could also imagine the man having a rope, attached to the box and pulling it along. And that's how you get something to move, straight. But what happens when you start to actually put force onto something? It actually starts to accelerate. And so that is like the fundamental thing is that in space, I don't know if any of you have ever heard of Newton's laws, but an object in motion stays in motion, or an object at rest stays at rest. So you must apply a force to something in order for it to change where it is going or how it is moving. And so when you push on something, it begins to move, and that's called accelerating. And that's what is happening to the box here in this lower corner. He's pushing on the box, and it is starting to speed up, just like how you might press the gas in your car and it starts to move forward. So how do we move a rocket? How do we accelerate a rocket? Well, we use something called a rocket engine. Who actually knows at a high level what a rocket engine is?
Raise your hand if you know. You may call on somebody to answer, Andrew.
Yeah, definitely.
Okay. York, I see your hand raised. So you can unmute yourself and then answer.
A rocket engine has a combustion chamber, a tank with LOX, that's the abbreviation for liquid oxygen, and a fuel tank, which is either kerosene or liquid hydrogen, and then those both flow into the combustion chamber, and then they are ignited. And it's not the fire that pushes the rocket forward. It's actually water vapor. And SpaceX produces one of two kinds of it. Produces two kinds of engines. So the Raptor engine and the Merlin engine.
All right, York, that was quite the answer.
The first stage of Starship has 33 Merlin and 33 Raptor engines, and the capsule of Starship has 3 Raptor.
Very good. Hey, York, I'm going to cut you off. That's an incredible answer for
that
whatever
was very
stage.
good.
that was beyond good, York. Okay, you obviously you like rockets. We'll have to hear more from you a little later.
That was equivalent to many SpaceX engineers' explanations. So that was very good. Yeah, yeah. So as York said, we have lots of rocket engines on the vehicle. You can see one of them here on the left. This is an example of a Raptor engine, and like York was saying, just like in your car, you need some gas and you need some oxygen, and you mix those together, and they create an explosion. And you have a big nozzle which directs that downwards, and pushing all of that combustion out the bottom actually pushes the rocket upwards. And that is how we actually push a rocket and make it accelerate. And you can actually calculate how fast something will accelerate very simply, and that is mass times acceleration. So the amount of force that you apply to something is directly proportional to how heavy it is, and then how heavy it is determines how fast it accelerates. So you can imagine for a starship, which is extremely heavy, all that fuel that my mom and York was talking about before, all that fuel has to be pushed and get up into the atmosphere and get into orbit. So you need a lot of energy and a lot of thrust using these rocket engines in order to push all of that upwards. And so you can see, if you ever watch a launch, you'll see the rocket accelerate very slowly at the bottom. When it's first taking off, it's very slow because it's got so much fuel. It's totally full. And then as it gets going into the atmosphere, it's getting lighter and lighter. So it keeps accelerating faster and faster and faster until eventually it has so much speed that it is actually in orbit around the Earth and will not fall back to the Earth without getting slowed down by the air or something, or by the atmosphere. So that is like fundamentally how we actually push rockets forward and get them up into the air and up into space. And the lighter your rocket is, the faster it goes to space, and the more payload, like satellites or people, you can take into space with you. So it's very important when we're designing hardware for the rockets that we keep them as light as possible so we can accelerate faster, and we can get to space faster and easier, and also carry more satellites and people. And it's very important to have a very light rocket in order to get to Mars because it's so far away. And on the right here, you can actually see the Starship taking off. So this is right at the beginning. You can see there's lots of orange and lots of fire. It's very exciting. We all love to watch it when it happens. So, but once you are in space, right, the question is like, how do you rotate in space? So I'm going to actually move my little Teams thing here so I can see my own slide better. 1 second. My mouse has disappeared. This is a big bummer. Okay. Yeah, how do you rotate something in space? So can anyone describe, or does anyone recognize what they see on the screen right here?
Calling somebody? Me calling somebody, Andrews?
Yeah, Braden, you can go first.
All right.
Are you talking about the space shuttle on the left or the graph on the right?
Either of them. I assume you'd probably recognize the space shuttle better, though. What do you see?
Thrusters on the nose, trying to orientate the spacecraft.
Yeah, exactly. So this is one of the primary ways that we actually rotate vehicles in space. We do not have any ground to stand on to push with or anything like that. So we actually use the same thing that we use to push the rocket up. We have smaller ones that are all over the spacecraft and actually shoot off in different directions in order to rotate the spacecraft in space. So on the left-hand side there, you can actually see a computer simulation of the space shuttle in space rotating using these little thrusters that are all over it. And at SpaceX, we use a very similar technology. You can see the Starship schematic over here on the right. And you can see I put some red arrows where you can actually see where we have these similar little engines, little rockets that help us orient the vehicle in space. It's a very tried and true technology, and so you can actually see the big rockets there at the bottom. You can see the kind of plumbing and the nozzles there, and that this kind of like basic schematic. And those are the ones pushing it forward because we want to go forward as much as possible. But when we need to rotate, we can use some of these smaller engines where the red arrows are coming out. And that's how we actually rotate the rocket in space. But in order to rotate the rocket, right, you have to know where you are pointing and where you want to point next. So the next question is actually, how do you know where you are pointing in space? I'm actually going to go quickly through this slide explaining some of the technical details. Oh my gosh, my slide is bad. So when you are actually using those small thrusters, remember before we were talking about a force, but when you use those thrusters, you create something called a torque, which is essentially a rotational force. And usually you can visualize it by imagine like holding your arm out and pushing down at the end of your arm. That's called a torque, and that's like acting on your shoulder. So that's how you actually rotate the rocket is you have some distance from your center of mass and you apply some force. And so that force arrow there is what the little rocket engines are doing on the space shuttle and also on the Starship. So again, we have our space shuttle, we have our Starship. How do you know where you are pointing and where you want to point? So I'm going to show you guys a little video here, and this is going to explain a fundamental example of how tons of rockets, most rockets actually in existence, know where they are pointing and where they want to point next, and how they use that information to control the little engines to push and rotate the rocket to where they want to go. Like, for example, towards Mars or towards the moon. So I'm going to play this video here and just watch and think of questions and like try and understand what you are seeing here, because it's very interesting and unintuitive. Oh. Okay, here we go. So you can see here, we have a bicycle wheel hanging from a rope, and it's only hanging from one side. Now, this man here is actually going to come and just start spinning the bicycle wheel as fast as he can. He's going to start spinning it. You can see the bicycle wheel is just still kind of loose, hanging down, just how gravity would just pull on it. And then he's going to turn it on its side, and then it is going to stay on its side.
Ooh.
And it's only hanging from one point. That rope is still only holding it from the middle. And yet it doesn't fall, or it falls very slowly. You can see as it rotates itself around, very controlled, and it's trying its hardest to stay upright, but it's not just falling down limp. And it's still kind of crazy to see every time I see it. Has anyone ever seen something like that before? It's pretty mesmerizing a little bit. And you can see it finally slowly comes down and now is back to kind of like a neutral hanging position. Does anyone actually know how that works? I can play it again while anyone would like to talk about it or answer. Does anyone know? No one? Yeah, York?
So it works. The bicycle wheel pushes the spokes. They're like, imagine a plane propeller. Let's do a little bit of an easier example first, so that everybody can really get the hang of it. So a plane propeller, it's a little bit slanted, and it spins so fast, and it needs to spin in a certain direction to go forward or backward. Now it's slanted. And if it does something like this, it is pushing air backward, which makes it go forward. If it spins the other direction, it goes backward. Now that's for a propeller plane. Jet planes is a whole different story. Now we're not going to do jet planes right now, but
That's close. That's a good answer. It's not quite correct. I think if anyone else has anything, I can actually reveal the truth here. It's not quite about the air. This also works in a vacuum. So if there's no air, this will also work despite having gravity. So what's going on here is that things that are spinning will always try and point in the same direction, even if there is a force applied to them. So this is called, it has momentum. Has anyone ever heard of momentum? I think usually we use it in terms of, stopping something that's heavy, that's moving, or, someone running really fast and someone trying to stop them. Well, the same thing also applies in rotation. So if something is rotating, it will try to always point in the same direction despite gravity or something trying to pull it and rotate it a different way. And this is because the momentum, there's a principle called the conservation of momentum, which I had at the top of the previous slide. So the way that they use this is, we discovered this, mathematically a long time ago, but they discovered in the 40s and 50s, and even earlier, that we can use this to actually guide rockets, because you can imagine if you started spinning that wheel on the ground before you launched, and then you had it suspended in something that let it stay where it wanted to point, that when you got into space, it would always be pointing in the same direction. So you essentially have a sort of true north, just like how explorers in the 1500s and 1600s would use a compass. It would always point north, and they could see where they were pointing relative to the compass, and they could always tell which way they were going based on where north was. Well, the same thing can happen in spacecraft. Where we have on the left here, you can see that golden part on the left is actually a spinning wheel, and it's spinning really fast. And when the rocket launches, that thing is spinning really quickly, and the sphere around it is assembled inside a mechanism that allows it to rotate freely in space. So the rocket can rotate around the disk. And so this disk, wherever that rocket is pointing, when it takes off, that disk will always be pointing in that direction. And then they can measure where the disk is pointing and where the rocket is pointing, and they can see the difference. So they can always know where they are relative to the disk that is always spinning in the same direction. And there's a lot of technical reasons how this works. It's obviously very complicated. There's a lot of nuance to it and difficulty, but that is fundamentally how most spacecraft over the last, 50 years, 60 years, 70 years, have actually controlled their orientation in spaces with these spinning disks that kind of look just like bicycle wheels, big golden ring on the outside, thin golden ring on the inside. And this is how rockets actually have been able to know where they're pointing in space before we had all these computers and everything. So we would use these disks. It would always tell you where your true north was, because that's the direction it was pointing when you launched. And then you could measure that, and you could tell your little thrusters how to rotate your vehicle in order to get where you're going. I just saw a couple people had their hand raised. Does anyone have a question?
One of them in chat says, what is the disk pointing to when you launch, Earth or to Mars?
That's a great question. It is not necessarily just pointing forward. It's different on every spacecraft. The most important thing is not that it's pointing towards Earth or towards Mars, but that it is pointing in a direction that is perpendicular to any one of your three axes. So we live in a three-dimensional world. So there's three dimensions. I don't know if you know X, Y, and Z. You can explain motion in three directions. So usually a spacecraft will have at least three of those, one pointing in each direction, so you can measure your rotation in each direction. And then it's not actually important where it's necessarily pointing, as long as you know where it's pointing. And then your programmers can program the computers to take where it is initially pointing and then create a pathway to Mars, to the moon, based on where it is originally pointing. It doesn't actually have to point anywhere specifically, as long as you have at least three of them and they're pointing, they're perpendicular to each other, and you can measure them, then you can know where you are in space.
Last question on that, Andres, is there a motor, and how does it keep spinning?
Yeah, so that is a great question. So the physics behind this are obviously imperfect.
Yeah.
Yeah. So it's very hard to, for example, keep it spinning, right? There's friction. It wants to slow down, just like that bicycle wheel did earlier. So they do sometimes use motors to keep them spinning. but every time you use the motor, you are putting energy into the wheel, and that can throw off your measurements just a little bit. So the more you use the motor, the more error you have, and that's just something that the computers have to adjust for.
Good. All right. Keep moving.
Cool. So this is the more technical kind of like nugget, but this is why it works. When you have a rotation, and you can see the kind of bicycle here on the left, you can see the string is the black line, and you can see the handles that were on the bicycle wheel, and you can see the rotation of the wheel. So you can see as that bicycle wheel was rotating, its momentum was pointing straight out, and that is how we define the direction of the momentum, is just straight out from the wheel. And so that momentum was pointing straight out horizontally. And so that wheel wanted to stay pointing horizontally, even though gravity was pulling on it and trying to pull it down. And the faster you rotate it, the stronger the force is that keeps it up. So you want as much rotation as possible. And you can see a little picture on the right. That's how you determine where the momentum is going. So it's called like the right hand rule. If you use your hand and you curl your fingers in the direction of the rotation, then your thumb is pointing where the momentum is. And that's where it's going to want to keep pointing.
Very cool.
So there's your little mini lesson. We use a lot of rockets use spinning wheels to know where they are in space, and then they will take that information where the rocket is pointing and where the wheel is pointing, and they'll know that's where we are. They know where they want to go, and they'll use those little rocket thrusters in order to get it where it needs to go and get it pointing in the right direction and then going in that direction.
Hey, Andres, they could do this wheel experiment at their home, right?
You can do this wheel experiment at your home. It's very easy to do. Just some string and some sort of disc that you can spin, and then you can pull it up on its side, and it will stay that way for as long as it can.
All right, very cool.
So specifically talking about Starship, does anyone know like a ton about Starship?
Brandon says a little bit. Let's see. Anybody? York says he does. Anybody else? All right, give a little bit. Why don't you go ahead and give some background on it, Andres?
Yeah, so Starship is the biggest and most powerful rocket ever made. It is designed to go to Mars and allow humans to have a colony on Mars. Get the first people to Mars, start a colony on Mars. It's not just designed to bring, 1-2 people and a couple cans of Coke. It is designed to bring massive amounts of cargo and vehicles and tools and habitats to Mars so that we can live there. And is also, as a bit of a side quest, planning to go to the moon as well, help out NASA and bring America back to the moon. And so that's what it says there: service to Earth orbit, moon, Mars, and beyond. Starship could theoretically be used. It has so much power that you could send, large satellites to even Jupiter, Saturn, wherever. So the biggest and most powerful rocket ever made, and it's super exciting to work on. So fundamentally, what is the Starship? So most powerful launch rocket ever made. You can see it on the right-hand side here. You can see on the top is colloquially what is known as the Starship. So that is kind of the second stage. And then you have the booster on the bottom, which is the big silver part. And both of these combined kind of are known as the Starship as a whole, but specifically that's what they're called. We've had 6 launches so far. I'm sure maybe some of you guys have seen them on the news. But the big deal about Starship is that it is going to be the first rapidly reusable rocket in the world. There is no rocket ever that has been fully reusable and rapidly reusable. And the definition of that is we want to be launching the same rocket with the same hardware and the same things with as little refurbishment as possible, and launching multiple of them the same day. Many other nations, companies are launching, one rocket a year, a couple rockets a year, and it's brand new and they throw it away every time. We want to use the same rocket multiple times a day, and that's how you're going to get it cheap enough in order to go to Mars. And one of the unique ways that we do this is we actually catch the rockets, so that we can just catch them, set them right back down on the launch pad, and then launch them again. That's the goal that we're working towards.
Hey, Andres, can you talk a little bit about where you work on this rocket? Somebody messaged that earlier. They asked exactly, where do you work in terms of the Starship or in terms of this? And I didn't really say it, neither did you either.
Yeah, so I specifically work on the Starship, the second half on the top.
The top part, that'll be the transport.
Yep. This is where people will be. This is where cargo will be. This is where, this is what will actually go to orbit and go to Mars. So I personally own vehicle testing for the entire ship minus the engines. So when the vehicle gets built, it comes to me. I validate and qualify all of the propulsion systems, all of the avionics hardware, and then I will deliver the vehicle to the pad, where they will do more testing, like static fires, like proofing the system with fuel. And so I specifically work on the top half. I do not work on the bottom half.
On the booster. Doesn't work on the booster.
Yep, I do not work on the booster.
Hey York, can you stop making marks on the screen, please? Otherwise, hey York, I need you to stop doing that, okay, buddy? Thank you.
So where does Starship actually launch? It launches exclusively in Boca Chica, Texas, which is where that little red dot is, that red star. It's the most southern point in Texas, and we're hoping to expand that to Florida soon. But right now we're only launching in Texas, and this is where not only the launch site is, but also the factory. So the second line here that says the factory is the product. That's a very important point, that SpaceX is not just building a rocket and developing processes to build a rocket. It is actually equally or more important to build the factory and the rocket factory. This is the big thing that changed cars 100 years ago. Before Henry Ford, people would build a car. But Henry Ford really designed the assembly line that allowed us to build thousands and hundreds of thousands of cars.
Hey, can I tell everybody about the launch pad a little bit?
Maybe in a minute. I think we can talk about it more closer to the end once I talk about some of the specific things here. So the goal is not only to build and reuse Starships, but we want to be building 100, 1,000 of these every year. So it's just as important to build a factory that makes rockets as it is to build the rockets itself. And right now our current target is launching one rocket per week in the next year. Something that's really interesting about Starship is a pretty cool technical item here, is that when the rocket is going up and the booster is going to separate from the Starship, so that the Starship can go to Earth, to go to orbit and go to Mars, and the booster is going to come back, the Starship actually lights its engines before separating from the booster. So here you can see a big thing that we did, where you see the Starship is actually turning on its engines before separating from the booster. And then it launches itself off of the booster and forward up into space. And you can see the booster starting to turn around. It actually uses and orients itself in a way such that the Starship rocket engines help it rotate. And so it's going to turn around and actually come back to the launch site. And then eventually it comes back to the launch site and gets caught. And this is something that we actually have done. No other rocket can do this. This is the first time it's ever happened in human history. And it's been pretty insane. I was there when it happened, and it was an awesome time. But this is fundamentally what allows us to reuse the rockets, is that they go up, they come back and land. If every time you went on a flight, to visit your family for Christmas or go on vacation, they threw away the whole plane, your flight ticket would be $10,000. And we don't want it to be $10,000. We want it to be $100. So yeah, you got to start reusing the planes. You got to start reusing the rockets. So that is our purpose.
Hey, Andres, I sent out the link to the video of it catching it. Did everyone see that? Did anybody not get to? Raise your hand if you saw the video that I sent the link to. Some of you. I have it here, Andres, if we want to show that.
Yeah, we can show it for sure. And I can give some behind the scenes commentary.
You let me know when it's an appropriate time. You can keep going if you want, or.
No, you can definitely keep going.
Okay.
I actually have it right here.
Okay, go for it.
I don't know if you guys can hear it, but.
Yeah,
This is the final go, no-go call to operations.
we can hear it. little bit.
And so this is our 5th test flight. You can actually hear my buddy Tristan talking. He's the flight director who runs us all through and tells everyone what to do and how to launch the rocket. You can see all that condensation coming off. It's because the fuel and oxygen is stored at negative 200 degrees, so it's very cold. You can see all that condensation. You see that hot staging that I talked about before, where the Starship launches actually physically off the top of the booster.
Where it separates.
30 seconds. So then we're checking everything, making sure everything is okay.
Stage separation. Upper the go vote is set true. We are go for catch.
You can see it starts coming back. And it is coming back so fast that the air itself is actually heating the bottom of the rocket red hot because it's moving at insane speeds. And I personally did not think this was going to work. You see the shock waves coming off of the rocket. And we were all sitting there. I was in there with them. And I was just like, oh my goodness, this is really nerve-wracking. And you can see we just set it down. Perfect catch on. This is the very first time we ever tried. And everyone, I don't think many people expected it to work, frankly. So we were all extremely excited that this happened. And then, of course, the ship kept going. This is what I personally work on. You can see we're coming back. We're re-entering the atmosphere. This is the first vehicle that ever allows us to get re-entry footage live like that. And it was landing in the Indian Ocean, so that's why it's nighttime. And you can see it lands in the water just perfectly, exactly where we wanted it. So that is the process by which we are going to catch the booster. As crazy that even happened, I don't think many of us thought it was actually going to work the first time, but it was crazy that it did. The booster team did a fantastic job, yeah. So right now these are just test flights. We're qualifying the hardware and making sure that it is iterating as fast as possible, so that we can keep developing it and building it and making it better and better. So we can get to Mars as fast as possible. So right now we're not actually currently carrying payloads. Right, the booster went up and came back and landed, and the ship wasn't carrying anything. It went in and went around the world, came back, landed in the water. Everything was awesome, and we're going to start flying satellites first in 2025, and then we'll continue to start building it so that humans can be on it, and then we can start sending them to the moon and Mars as soon as possible. So.
Anders, when's the next test flight?
Next test flight is currently scheduled for January 6th-ish. We're launching them as fast as possible, so there's not a lot of margin. We're not like, we got some date that we can definitely hit. That's our current target, but that it can be anywhere within there. So if you ever want to come down and watch one in person, it can be a little tricky with the flights, but somewhere around January 6th to 10th probably is my guess.
Anders, is this a good time to take a few questions about that?
Yeah, definitely.
Okay, I'm going to read a couple that came in through chat. So that's a great video. Let's see. Is the booster programmed to land, or is a person controlling it?
Yeah, so the booster is everything is fully controlled by computers. So no person ever actually controls where it goes. It's fully programmed by computers, but humans are in the loop a little bit. So, for example, on this specific mission, we had 3 people who were actually physically involved in controlling where the rocket went. They didn't have a joystick or anything, but once the Starship separates and goes off into space, and the booster is turning around to come back, there's one representative from the booster who is evaluating all the hardware and health of the vehicle, and he has to hit a physical button that says "Return to the launch site," and then there is a representative from the catch tower, and he has to evaluate all the hardware and health and say, good to return to catch site. And then Tristan, the flight director, he has to take both of those inputs, and then based on his own information, he has to give the third and final go for return to launch site. So if they don't press those buttons, then it comes back and lands in the ocean. And if they do press those buttons, then it comes back and lands at the tower. So they're not physically controlling where it goes, but they are giving it instructions about like high level objectives.
All right. Couple other questions. Are you still good for more questions?
Yeah.
Okay. So somebody asked, how are you going to reuse the Starship if it lands in the ocean? So.
Yeah, the Starship. So we're landing it in the ocean right now while we qualify it to feel comfortable with it flying over populated areas. The booster actually comes back over the water, so it's not really a risk to people. But the Starship is going to be coming around the other side of the world, so it's going to be actually coming over not the coast but the land. So we want to make sure that vehicle is super robust before we have it re-entering and then performing boost back burns and landing burns over populated areas before it gets to the tower. So we're being a little bit more cautious. The other thing is that right now we only have one catch tower, so we can only catch one vehicle at the current moment. So right now we're landing the ships in the water, and then as soon as we have the capability to, we're going to catch the ships as well.
And then there's a question, how heavy is the booster? So I guess maybe at launch versus on catch. Maybe you can talk about those.
I do not know how heavy it is at launch. I think empty, it's about 180 tons.
And so how much fuel does it take to get this rocket off the ground?
Oh man, a lot. A lot. I do not know. I don't know exactly how many pounds.
All right. Let's see. Somebody said to watch out for aliens. If you're going to populate Mars. How long does it take to build a rocket? That's a great question.
Yeah, so right now we finish building a rocket, around once a month. That's about the rate that we're achieving right now. But of course, that's like an assembly line, right? From start to finish, probably talking. I have to think about when the first pieces came together. I would guess 8 months to a year, I think, is the current timeline. Sounds about right.
And maybe talk a little bit about they were when you started a year and a half ago, they were manufacturing the rockets in tents, and it was a much slower process. And then you talk about versus what they're doing now with the new rocket factory that was just built.
Yeah. So when I started it, we've been changing everything very much all the time. So when I started, we were building these in tents, like literally. We did not have actual buildings for the vehicle production. So, we were just building them as fast as we could in these tents, but obviously it was a lot slower. We had a lot less people, a lot less tools. So we were, much slower. But now we have the factory. We're investing so much in our procedure and everything that we've improved that, so much to close to 1 a month release. So, having a building and not building your rockets in tents is a good thing.
All right. This is a good one. How do you get the pieces for a big rocket?
Yeah, that's a very complicated process. Some of the pieces
Maybe
we can
talk about the rings and the assembly of the rings.
Yeah, I'll talk about the actual assembly a bit later. But yeah, it's some things you can just buy. A lot of it we just have to make ourselves. We want to keep everything as much in house as possible so that we can control, how good it is, make anything better that we need it to be. Not be dependent on other companies that maybe have other customers or things that have different requirements. So we want to be able to. So we try and make as much in house as we can.
Okay. And then what happens to the Starship when it lands in the ocean after it lands?
So once it lands, generally a couple things. I'll just have this playing in the background. Oh man, make this less loud. Once it lands in the ocean, we kind of have two paths forward. We do have a group of people that are there in case once it lands in the water, it wants to tip over, and that's when it's empty, it's not very strong, so it can want to crumple in certain ways. So we do have a team of people there that would like to tow it back to with a little tugboat to Australia, and so that we can inspect it, do more things, or sometimes we just shoot it with some guns so that it kind of blows up and sinks. So, but that's very short term. We should be not landing in the water anymore very soon.
Okay. How long before humans step on Mars?
I think the goal is for the first ships to go into Mars in 2026. So I forget exactly what the timeline is for humans on those ships. I think maybe it was 2028, or maybe humans is 2026 too. I have to look at our plan, but one of those 2 years.
Okay. All right. Do you want to keep going with your presentation then? And somebody asked for the link to the video that Andrew shared. We can send that out. Okay.
Yeah, definitely.
Actually, I sent one in the invitation. There was a link to it was a different shot than that. Also, somebody asked about how they can watch it without the ads on YouTube. If you go to SpaceX.com, whenever there's a launch, there is a link there to the direct SpaceX feed. And that particular feed is very interesting because you can watch the engines and which ones are ignited and which ones aren't, and it's all on the bottom of the screen. I don't think it was on the shots that you were showing, Anders, there, but the SpaceX one, you can go there without any ads.
Yeah.
All right. So why don't you keep going, and then we'll go back to questions if we have time.
Yeah. So obviously, this is all to go to Mars. This is kind of what we envision happening in a few years. The rocket is improving so much every day. And we have a big version change coming up that's launching on this next launch. So a lot more performance, a lot more reliability. And of course, the goal of SpaceX is to always just iterate as fast as possible, test it, blow it up, come back and make it better. Instead of just trying to, from the very beginning, build a rocket that's going to go all the way to Mars with people on it. I don't think anyone really knows how to do that yet. Or did, in 2015. So we're learning how to do it while we're developing what we need in order to succeed at that. So, and then also, very soon, this is the same rocket, but just a little bit different without wings. That'll be used for landings on the moon.
And when is that going to happen?
I think 2026-ish as well. The actual thing, right? So going to Mars is very expensive, and we are not a government, so we have to, right? We are self-funded. We're not using, grants or just free money from the government in order to do this. So we have to be smart with our money, and we have to also make the money in the first place. So the way that we do that is by being an internet provider, and what we do is we provide internet to anywhere in the world that has a view of the sky, which is everywhere. So we create these satellites that orbit very low, and you can actually connect to them with a little dish that you can buy, and you can have extremely reliable high-speed internet anywhere in the world all the time. And this is really becoming, a real game changer because, expanding internet access to, all these people that didn't have it before, these billions of people that didn't have access to all of the information. Having access to the internet is a total game changer. And whether it's because of, the governments or anything else, making these broadband internet, ground-based internet pathways is very expensive, hard, and takes a lot of, convincing, like for governments or companies in these countries. So we're like, let's just give everyone internet all over the world, totally changing people's lives, and being like the internet backbone for the world essentially. And so, we have like lots of nations all around the world, like in Africa, where the way you get internet is through Starlink, which is the internet program, and it's like really just improving lives and making a real difference in all over the place. And all that money is going straight towards, making the internet better, and then also going to Mars. So that is how we make the money. That's how we have the money to make a Starship, or many of them. What I do specifically, so I mentioned a little bit earlier, but I'm a Starship engineer. We like to not have like super specific titles because really you're just a problem solver who is fixing whatever they can to make the vehicle and program better. But specifically, what I do is I'm a test and integration engineer, working in like the production operation. So I have been in charge of actually building the vehicle, and also right now I'm primarily testing the vehicle. So I own, and it might sound a little weird, right? Like I own integrated vehicle production testing. SpaceX is extremely ownership based. You are the extreme owner of whatever you do. Your name is next to it. If someone has a question about it, someone can reach out to you directly. Every single part, every single process, every single tool has someone's name next to it, so that it can always be, someone can find you, ask a question, someone can understand where a requirement came from, someone can ask you if you need to make a change to something to make it better. You are the extreme owner of everything that you do. So the thing that I own is integrated full stack Starship vehicle production testing, which is known as checkouts. We work a lot of long days and a lot of weekends. But when you're climbing around inside a Starship, it's hard to remember that it's Saturday.
So your arrows are pointing to something specific there?
Oh, yes, yeah. So on all of the flights that you have seen so far, except for the very first launch, I actually was the owner of installing the aft wings, which we call the flaps. So I was the engineering owner for getting those wings installed and installing all of these sections of the heat shield, and then also fully qualifying the vehicle before it exited production and went to the pad. So those are the three big things that I did for the first year-ish, and then I pivoted to solely doing production vehicle testing in the last 6 months for the new ship design. So those little flaps that were working so hard on all these launches, it was very exciting to see them go because I got to install them. So very exciting.
And then the heat shield is on one side. You want to talk about that? That's the black part. Those are the tiles.
Yes, yeah. The heat shield is the black side. It's because that is the side that we want facing forward when you're going through the atmosphere. So you want a lot of heat resistance on that side. So we have these special heat shield tiles similar to what you see on like a space shuttle or something on that side specifically, so that it doesn't overheat and melt.
Very cool. All right.
Yeah, so you can see this is actually where I worked for the first year and a half. This is called the high bay. This is where we built the full stack ships. And this was actually our busiest day in the high bay. When this photo was taken, you can actually see we had four starships in the bay at this time. So this was the only time that ever happened. When I was doing this, the vehicle that was in the latest launch that was carrying the banana, if anyone ever saw, was that vehicle on the right. And I actually was the owner of that vehicle at the time when this photo was taken. And I was doing a lot of testing, a lot of integration. We'd installed those wings, as I had said before, and doing all sorts of things with the satellite deployment mechanism and everything. So this was a very busy time for me, especially when there were all these ships. We were all clogged and didn't have a lot of good access to what we wanted to do. So, but the rockets have moved out of high bay, and now we have a brand new building where we've been doing this. So this photo is a bit nostalgic because I'll never actually be working in this space anymore. But how we build starships is a question that someone asked earlier. So you can see, let me move my thing here. Yeah, so you can see kind of working from the smaller ones in the middle to the left. This photo isn't like exactly perfect, but this is how we actually build a starship. So you kind of, like with any problem, what do? You start small with what you can understand and do, and then you kind of build it and make it bigger. So what we do is we kind of make these rings of stainless steel, and you can see those kind of in the middle. And we make them in the factory, which is why the factory is, kind of like a normal height building, and the bays are so tall. We build all these rings in the factory, and then we, put tubes in them. And we put, electronics and all of these things, and then we kind of stack them on top of each other until the rocket grows and grows and grows and grows. So you can see there's all sorts of engineers and lots of people working on all of these sections, and then they get shipped out to the high bay, which is the building I just showed you. And then we'd pick each one up with a crane, and then you kind of lift it up and you slide one underneath and you weld it together. And then you pick it up and you slide it in and you weld it together, and you keep doing that until you get your full starship. And then once that starship is built and is now stacked, as we call it, then that's when I would receive it and throw on those wings and do the testing. Yeah, so how did I get to be at SpaceX? I kind of just was always interested in technology. And in high school, I kind of pursued that deeper. I did a robotics team. I was helping with home hacker camp. I was just following my passions of playing a lot of soccer and just tinkering with electronics and things like that. And then I knew I wanted to do engineering, and I kind of chose aerospace because I thought planes were cool. And so I went to engineering school. I still played a lot of soccer. Important to have a lot of extracurriculars and have fun. And the most important thing while I was in engineering school is, while grades are important, the really thing you want to do is figure out what you want to do for your job and get good experience. So I was really focused on getting internships that I thought were interesting. And despite, them not being, the best paying or the best wherever in any sort of way, I just really wanted to get good summer engineering jobs that would give me good exposure. So, and while at those internships, the thing that actually got me my job at SpaceX was that at my previous internships, I tried to make things better where I worked. So SpaceX is extremely serious about not just performing your task or, doing what you're told, or, just kind of doing the same thing over and over. Even if it's good, you want to make what you're doing better. And the best thing is actually if you can make it so good that you can delete yourself from the process, so you don't even have to work anymore. That's the best part. So if your job is to make something, if you can make something physically, if you can automate that and make it so fast and so good that you don't even have to be involved, and that's the best thing. So that's the number one thing that SpaceX looks for, is that you took some process or thing or tool or anything that you're doing, either in your hobbies or at your internships, and you made them better, and you deleted steps, you made them more efficient, you made them cheaper. That's the thing that cares. Obviously, you still want to do a great job at kind of doing what your job is, and whether that's making parts or making drawings or things like that, but you want to always be trying to show how you took what you received at the start and how you made it better by the time you left. And so that's like the most important thing by far. And then, of course, I applied to a bunch of positions at SpaceX and surely got some amount of luck in my interviews, and it worked out. And here I am. I see someone have their hand raised.
Hey, Andres, somebody asked, did you invent anything for SpaceX or for your previous internship?
Yeah, so the thing that at my previous internships, the most important thing that I did that like really hooked the team that was interviewing me was at a company called Sierra Nevada Corporation, which they're another aerospace defense contractor. They make a lot of planes, a lot of aircraft modifications. When I had started, I was kind of like doing some, intern things that weren't super high value. But there was a problem that came up where we were designing a plane, and we didn't really, we had very strict requirements from the government on how high it had to fly and how far it had to go, and so we needed to size, the wings and the actuators that made the wings, deploy and stow. We didn't know. We were trying to figure out how much. We were trying to quickly, analyze different wing types to determine, what was too much drag or what was not, what was. We wanted as much lift as possible for as little drag as possible. And the way that a lot of teams do that is they use like a supercomputer to analyze, the flow of like molecules over the wing. It's very intensive, and our supercomputer was just always so busy with other projects that it kept delaying us because we couldn't say like this wing is too bad, this wing is fine, super quickly. So what I did is I actually, using a lot of what I learned in school, developed a tool that is analytical, so it doesn't require any simulation. And what it did is it actually calculated based on wing characteristics the drag that the wing would show at any angle against the airflow. So the thing that I did is I took, a process that we were super slow on and getting supercomputer simulations for. I created a tool using MATLAB, which is like a programming language, and Excel, and created a tool that you could take the exact same things that you would put in the supercomputer, and you'd put it in, and it would calculate very similar data in like 3 seconds. And it was, within 10% of what the supercomputer would say every time. So that was the big thing that SpaceX was impressed with. That probably got me my job here. And then at SpaceX, what did I invent? A lot of the things that I do at SpaceX are like processes. So I develop tools and processes that make qualifying a spacecraft faster and easier and better. So I have a lot of tools, a lot of processes under my belt that I've developed that we use to perform vehicle checkouts. I've also designed some hardware as well, and rolled out changes to the boosters and the starships in order to make them better. So have some flight hardware as well under my belt.
Very interesting. I didn't know that, Andres. All right. Somebody said, can I start with mechanical engineering and end with aerospace engineering, or start and finish with aerospace in college?
You can definitely get a job at SpaceX with almost any engineering degree. SpaceX almost does not care what your engineering degree is, as long as you do well and have good internship experiences. It's really like, if you're good at electrical engineering, and even though you have a mechanical engineering degree, SpaceX isn't going to hire you as a mechanical engineer if you want to do electrical engineering and you're great at electrical engineering and you have a lot of experience in that. So I wouldn't stress about, oh man, is it mechanical or is it aerospace or this or that? You will be able to get a job at SpaceX with any of those things, no matter what. It's just about the experience of what you want to do. For example, I have a kind of co-software team that develops all the software that, I work with them to create a lot of software that we use. And none of them are actually software engineers. None of them studied software in school. They all just kind of started working at SpaceX and then decided they liked software. And then they all became an entire software team together. And none of them studied software in school. So I wouldn't stress about, oh, mechanical versus aero. Like, just do what you love and what you think you'll succeed at, and then SpaceX will surely have a spot for you.
So we're a little over time, and I'm just going to go ahead and let people ask questions. If anybody, if you have to drop off, that's fine. We certainly understand, but we want to give people an opportunity to oh, this is his cat. That's Kayet. Nand, I'm going to call on you in just a second, but somebody asked a couple of times about what software they use for, I guess, designing the rocket, like Autodesk or, and then what stainless steel do you use? I don't know if you have quick answers for those, Andres, because we want to answer a few more questions of other people.
Yeah, the CAD is primarily in Siemens NX, and was there another software part of that? And software wise, it's like a lot of Python.
Okay. And then Nand, I don't see your question. I just see your hand raised. So if you want to ask your question. Oh, did you drop off? Nand was politely raising his hand for a long time. Sorry. Okay. Did you drop off, Nand? All right.
I don't know if they know that they're Nand.
Okay. Let's see. Do you use any CAD software? I think you just answered that. Does the booster use AI to return, or can a person override it?
Person can override it. I don't think we're using any AI at the moment. You can have really advanced control logic without AI. So, but who knows what holds, what's in the future. But yeah, I would guess no AI right now. Okay. And you can override it.
Yeah, because you guys can explode it on demand, right?
Yeah.
And then somebody said, why do you shoot the rocket?
Yeah, so the rocket is like, a big tank of fuel. So if it's empty, it'll float, it'll just like float around in the ocean. So if we don't want to recover it, you don't want a big piece of, special military grade missile technology floating around, and some foreign nation will go get it or something. So we shoot holes in it so that it'll sink.
Does SpaceX do tours at their facility? Do you want to answer?
Yeah, all of them do. You have to either be a part of an organization though that has a tour or know someone who works there.
All right, and I'm going to touch on that again in just a second. I'm actually going to try and get together some sort of SpaceX tour at some point. I don't know exactly when yet, but I am thinking about that. So as a field trip for homeschool students. So I don't know if we'll be able to get inside, but we can certainly do outside and get a lot of detail. So that is something I'm thinking about. I haven't moved forward on it yet, but that is in consideration. Nand, if I'm not saying your name right, your hand is raised again. If you can go ahead and ask your question. Sasha says one-way trip. Nand, go ahead. Unless I'm not saying the name right.
Can you hear me?
Yeah, go for it.
Yeah.
There you go.
How do people get back from Mars? You said how the half of the spaceship gets back, but you didn't say how the other half did.
Yeah, so when the Starship, which is the top half, goes to Mars, the first lot of them will be staying on Mars. But the plan is the actual reason that the fuel is methane and oxygen is because you can make methane on Mars and refine it, very easily comparatively. So the Starships will land on Mars, and then they'll be refueled while they're there, and the Starships can fly back. And Mars is small enough, you need a lot less energy to go from Mars to Earth than from Earth to Mars. So Starship can fly back from Mars by itself.
Who else has a question? You can raise your hand. Electronic hand, I can see that easy, or you can put it in chat. Anybody else have another question? Okay, Braden, go ahead.
I actually do have many questions. I'm just going to try to limit it to just a couple. One thing I was wondering is how do they get it to the launch pad? Because I know that NASA uses the tank-like thing. But how does SpaceX carry their rockets to the launch pad?
Yeah, we have these rovers that we get kind of off the shelf from, a company that makes them. They just are used to carry heavy things, like at all sorts of industrial sites. So they're kind of like these big rovers that are, maybe, small car width wide and 50 feet long, and they kind of like drive underneath the Starship, and then just kind of like there's two of them, and they kind of drive underneath, and they pick it up, and then they just drive it out to the launch pad. Only takes us about an hour to go from the production site to the pad. It's super easy, super quick, super cheap. There's just like one guy with a Xbox controller, and he just kind of like drives it around. He's a cool guy.
Is there a limit to how many questions we can ask? Because I don't want to take too long.
Why don't you go ahead and ask one more, and then Andrew, you'll be next.
Okay. For the you said how it ignites before disconnecting from the booster.
Yep.
But wouldn't that cause a bit of erosion, which would make the refurnishing process harder for the next reusable flight?
Yeah, it definitely does erode some, but we really armored up that. It's called the hot stage, which is actually like a piece of hardware that sits on the booster that kind of like deflects the fire outwards and like around the booster. So we beefed that guy up pretty big. I'm not sure what the like super long term vision is for that hardware or how hard it is to refurbish. I don't quite know myself on the material side, but you gain so much performance by hot staging that it's definitely like worth it right now.
All right, Braden, we'll come back to you if we have more time at the end. Andrew, go ahead.
I was wondering how do you get all the ingredients if you're going to make a city on Mars get there?
Yeah, that's a tough problem. But the answer is right. There's not much on Mars, so the answer is get as much stuff to Mars as possible, and that is only going to be possible if it's super cheap. So that's why we have to be able to reuse these things, over and over and over. So you just keep flooding Mars with hundreds and hundreds of starships, and just bring everything you can possibly think of. Just attack the problem full head on.
Very good. All right, Nicholas, you're up next. Question, go for it.
So what kind of gas does the rocket take?
Yeah, so it uses two things in order to create thrust. It uses liquid methane and liquid oxygen. And when those both mix, you can light them, and that's how we create thrust.
Liquid methane and liquid oxygen. Okay. How long does it take to get to Mars? That's a question from the stewards.
Depends when you go, but the shortest time is about 3 months. And the more powerful your rocket, the faster it is. So 3 months to get there is the kind of target.
All right, so there's an orbital, and you'll say it much better than I, Andrews, but there's an orbital time that is we're more closer to Mars, and so that's the window in 2026, and that's why they really want to try and do it in 2026, correct?
Yeah, there's a window like about every 2 years where Mars and Earth are close together. So you want to go when it's close together and not, on the other side of the sun.
All right. How do you plan on getting artificial gravity on the Starship, or is artificial gravity not planned for the Starship? That is from Tanya.
We're not planning to use artificial gravity. It just doesn't actually help you a ton. But, it would be fairly easy to do if we wanted to, because you just, spin the rocket. But having
I was going to say make it spin. I was going to say make it spin very slowly. Just spin the top of the rocket.
Yeah, you can spin it, and that would give you something. But it's, 0G is pretty comfortable. So it's not, you don't really need it.
Okay. From Sasha, she asked, do you need to create some fuel stations during these 3 months to fulfill refuel tanks along the way?
Yeah, so we do have to do that. The the way that we're doing that is the booster will launch the Starship. The Starship will, push into orbit, and then the Starship will be refueled in orbit by other starships. So we'll, launch like I think right now it's like 10 follow-up tanker ships, and we will dock them to the Starship, and they'll put fuel into it, and then they'll go back down, and then another one will come, go back down, and then once the Starship is totally full, then it can go straight to Mars on its own.
Right, Andrew, did you have another question? And then Braden and
What are the different parts of like all the parts of the rocket?
All of them?
I gotta learn another.
Yeah, at a high level, it's right. You have a structure, so that's kind of like the skin of the rocket, and then we have our main oxygen tank and main fuel tank, and those are both feeding into all of the Raptor engines on the bottom. And then above the tanks, you have the payload bay where you have your cargo and where people would be. On the current versions, we have a giant thing called the PEZ dispenser within the payload bay. You kind of stack satellites into, and then it shoots them out into orbit. And then above the PEZ dispenser, you have two smaller tanks, which are called the header tanks, which each one holds methane, one holds oxygen, and those are what are used for landing. And then all around the inside, you have flight computers and data acquisition units and small prop, which is like pneumatics lines for valves and solenoids to open and close, the fuel pathways and things like that. And then, of course, you have the flaps and heat shield tiles and some Starlinks on it so that we can send video back.
Good. All right. Braden, do you have another question? All right, we're going to take one or two more questions, and then we'll go ahead and wrap it up.
How many would you want? How many questions? Because I actually do have 5, but I think that might be a bit too many.
Why don't you ask one more, and then if somebody else has another question, then we'll give you another one. How's that? Oh, York raised his hand. So we'll give you one, and then York a question.
Okay. I've seen videos on it, and the Raptor engines are one of the first ones to how the turbines use some of the fuel to spin them to pump more fuel in.
Yep.
But like what's it called? When
full flow stage combustion.
Yeah, that one. How much more more do you get with doing full flow stage combustion as opposed to just like the LOX?
Yeah, I do not know exactly. I would guess that it's in the like 10% range or 15%. I'm not sure though. I guess it's around 10%.
Okay, let's see. York had a question, and then there was someone else who raised it afterwards. So, York, if you can ask a concise question, and then there was somebody else I wanted to give them a chance who didn't have a chance to speak yet.
So, how does the tanker actually transfer the fuel into Starship?
So we have some stuff in design yet, which I can't quite talk about. But I've been involved in. We've been designing it all actually right now. So you'll see more info on that soon.
There was somebody else who didn't get a chance to talk that raised their hand. I saw their name and then it disappeared. Was there somebody else who didn't get a chance to ask a question? That wanted to ask one? All right, final call for questions. All right, Brandon, nobody else has got their hand raised, so I'll let you go ahead and ask the last question. Braden, sorry, said Brandon. Braden.
Okay, is it? And I do. You guys can hear me, right?
Yeah.
Oh, and you know what, Anders, after his, then somebody's asked like 4 times where launch is always by ocean, so you can answer that after Braden.
Okay.
Okay. And while it's not exactly the part that you're working on, I have been confused as to what the grid fins are for, because I do know that they contribute to the precise landing, but I didn't know what exactly they do. Like, are they rudders or something?
Yeah, so the way the rocket actually steers when it's launching is mostly using the engines on the bottom, and they can kind of like rotate in like each direction, and that's how it actually steers. But when you're coming back, the like engines are not firing, so you need to have some other way to like rotate the rocket and glide it. And so the grid fins are like essentially hypersonic rudders. And they have like lots of holes in them, and they tilt and kind of like using a control algorithm can like guide and kind of fly the rocket back to the site.
Thank you.
All right, and then the last question was about oceans. Somebody asked several times that, and I didn't get.
Oh yeah. Yeah, so the reason we fly from the coast and go over the ocean is because rockets are dangerous, and so you don't really want to launch them directly over people. So usually like to launch from the coast so that you don't have a possibility of raining, debris down on, some city.
All right. Very good. All right. All right. I'm going to take, I know I keep saying last question, but Nanji, go ahead. Or Nand or Nandj. I'm not sure if I'm saying that right. You go ahead.
So NASA has launched. So NASA has rovers on Mars. Have you ever encountered any of those with launching rockets? And are you and NASA competitors at all?
It's a good question.
Yeah, I have not encountered any of the rovers. We have not actually landed a Starship on Mars. So and there's only a few. Mars, Mars is a whole planet. So it'd be pretty cool if we could have a little collab on Mars with a rover and some people. That'd be pretty exciting. NASA and us are not competitors. They're actually one of our biggest customers. And there's no like current program really that NASA has that we actually compete with. The main one I think people think about is Artemis and like SLS, but actually the SLS and Starship are both contracted to complete the Artemis program, like as partners, and are both like fulfilling different parts of that role. So there's actually no like real competition between us for any like program or project.
Very good. All right. Well, you guys are awesome. You asked a lot of great questions. Any last comments that you'd like to make, Andres? And we're going to go ahead and wrap up. We're way over time. Just want to give you guys the opportunity to ask as many questions as you wanted to. Any last comments?
I don't know if I have anything else. Just have fun in what you do, and if you end up at SpaceX, just give me a call.
Somebody asked about internships. I would say do any, whatever internships interest you. Exposure to anything is great. Problem solving, I think, is the key thing. Somebody asked those questions. Yeah. All right. Well, very good. Well, thank you all for joining. I'm so glad that we had the opportunity to do this. And somebody else asked if you had been in space. Andres has not been in space. I do not want him to go to space. I don't want him on the rocket. I want him on the ground. So he's not been to space. That was another question that came through a little while ago. So thank you all. Have a wonderful day. If you're interested in our classes, feel free to check out Home Hacker Camper robotics and programming classes. Andres actually does some of the recordings on some of the self-paced classes, and so he does some of those. So if you'd like to take any of our classes, feel free to reach out. All right. Take care, everybody. Have a wonderful afternoon. Right. Take care.
Bye.
Say
Thank you.
Bye-bye. Thank you.